Now look here, children, question number 2. A stationary body is acted upon by a number of forces. State the two conditions which must apply for the body to remain at rest. We have a body which is acted upon by a number of forces, and the conditions you have to mention that the body still remain at rest position, children.
Zero resultant force.
The sum of the forces must be 0.
Okay,
yeah, the resultant force
the sum of the forces. So sum of the forces means I can write that sigma F is equal to 0. This letter means, children, that the sum of all forces. Okay, all forces. So this should be equal to 0. The second reason, second point, you have to write 2 points. 1 point, if you write 1 marks, you will get.
It must be at equilibrium or something.
Yeah, equilibrium means, yesterday we have discussed about to achieve equilibrium. So you can write here anti-clockwise in terms of moment. Anti-clockwise moment is equal to the clockwise movement. If this condition is also satisfied, then still the objects will be in equilibrium condition or at rest position. So these are the 2 points, children. Now question number B part. Read carefully children's statement. Observe this diagram. This diagram shows a device used for compressing crushed material. Okay, lever arm is there, plunger, cylinder, crushed material, cross-sectional area, and one force is acting 20 Newton, and this force is acting, the distance is given. What is this H here? What is this H here? That possibly that the axis. The lever arm rotates about the hinge H at its right end. So this beam is, lever arm is able to rotate about the point H. A force 20 newtons acts downward on the left hand side. The force F of the crushed material on the plunger acts upwards, as in the diagram which is given. Ignore the weight of the lever arm. Then you need to calculate, children. Use the clockwise and anti-clockwise movement about H to calculate the upward force F which the crushed material exert on the plunger. The distances are shown in diagram. So here, we need to calculate this force. How much force is this acting? And so if this force is acting, I can make it that this is basically acting here in the upward direction. Okay, so you have to calculate this force. To calculate this force, what should I do? Now here, look at the force acting, that the 20 Newton force which is acting to the left side of the lever arm. And if I apply the concept of moment, means if I find moment due to the 20 Newton force, this will be, the equation force multiplied by the perpendicular distance. What is the force here? This is 20 Newton acting, this one. At what distance? At what distance, children? From the H. You have to look for the distance of this force from the pivot. This beam is rotating about H. So this distance is 380 plus 120, which is equal to 500 millimeters. 500 millimeter. So I will write here the unit force in Newton is given and the distance is in millimeter here, equation number 1. Suppose. Come to this force which we have to calculate. Yeah, okay, sorry, I forgot to write due to this force, and the moment direction is that this will rotate in the anti-clockwise direction about the point H. Now I will find the moment due to the unknown force F. that is equal to again the value of the force F and its distance from the H point, which is given 120. And this is F into 120 Newton millimeter second equation. And I have to mention here the direction of this moment acting here at this point due to the force F. May I know the direction, children? Clockwise or anti-clockwise? KZF.
That's
Anti-clockwise.
clockwise. That's clockwise, right?
It
It
will,
goes up.
yeah, it will be clockwise, children. Okay. So when a force acting here, and this will make the hinge, this lever arm will rotate in the clockwise direction here. So I will.
Oh yeah, clock.
It is a clockwise direction. Okay. You have to be very careful in writing this value. And in this question, if I read again, sorry, where is the statement? They said using the clockwise and anti-clockwise moment about H, calculate the upward force F, which is crushed material exert on the plunger. The distances are shown in figure 3.5. So if I apply the principle of moment here, and according to that, the clockwise moment is equal to the anti-clockwise moment. So then if you equate both these equation, then you will get the answer. This F will be equal to 20 multiplied by 500 divided by 120. 10 cancelled. 4 3s are 4 5s are, and 50 multiplied by 5 is 250. 250 divided by 3 is 3 8s are 4. 3 3s are 9 and 3 3 3 3. So this F is coming out, children, 83.3 Newton. So this force here, this is acting 83.3 Newton. Is this clear, this question, children?
Yes.
Yes.
Now, okay, now the second part. The cross-sectional area A of the plunger in contact with the crushed material is 0.036 meter square. Calculate the pressure exerted on the crushed material by the plunger. Pressure exerted on the crushed material by the plunger. Okay, look at the diagram again. The figure.
Force given.
Force we already
F.
calculated here. Okay.
83.3 divided by the area, right?
Yeah, very good, very good. So
Yeah,
children,
Newton. Units need to be the same as well.
So children, here you know the equation of pressure, that force upon area. Force I calculated, that is 83.3 divided by area is given here. You have to put this value here, 0.0036, and when after dividing you will get the answer. May I know the answer, children? Please divide it. And calculate it, please. 83.3 divided by 0.0036.
Yeah, 0.023 approximately.
2313, 8.8.
Yeah.
Yeah,
23,138.89.
amount of
Yeah.
this amount, this part.
Oh,
Pascal.
So that is the answer for this question, children. Question number 5. Complete the following statement. The moment of a force about a point is the moment of force, torque. Torque about a point is what? Force multiplied by, children, multiplied by what?
Perpendicular distance.
Perpendicular distance.
Perpendicular distance. Yeah, perpendicular distance. You have to write perpendicular distance from the what is this perpendicular distance?
From the pivot.
From the pivot. Okay, yeah, that you can further write from the pivot also. From the axis of rotation, you can say. 1b, sorry, 5b. This figure 3.1 shows a uniform iron bar having weight 30 Newton. Length is given. Bar is being used to lift one edge of a concrete slab S. Concrete slab, you can see here it is. A stone placed 0.20 meter is the stone, and that acts as a pivot. A force of 40 Newton, it is here on the right hand side, and that is able to lift the slab and hold it as shown. On figure 3.1, draw an arrow to show the weight of a bar be acting from its center of mass. Center of mass topic also we discussed, children, that it's a uniform bar and its length is given 1.40 meter. So its center of mass will be at the center of this bar. And what will be the its center, as the length is given 1.40 meter. So with the help of scale, children, that let me put somewhere in the middle, exact in the middle, the weight is here. You have to put an arrow, this side, draw an arrow to show the weight. So this weight W is equal to 30 Newton. Exact you have to put at the center of this bar, children. Okay, in exams, with the help of the scale, you can mention at the middle point. And so this distance I can write here if it is required in next question. So this distance is 0.70 meter. Now here, state the distance D of the center of mass of bar B from the pivot point. Distance of center of mass, children, from the pivot.
Isn't it 0.70?
No.
It'll be 0.5 meters, right? Because
0.70
Yeah,
minus
from the
0.20.
pivot point.
Yeah.
Yes, this is
0.5.
this is the axis pivot actually. So from here, let me use this black pen. This distance will be we are looking for. So 0.70 minus 0.20, sorry, it is minus. 0.70 minus 0.20, that equal to 0.50 meter is the position of center of mass from the pivot point. Calculate the total clockwise movement about the pivot of the forces acting on the bar. Total clockwise movement. Total clockwise movement. It means there are two forces acting, maybe more than one. That's why they use the word total clockwise movement about the pivot. So what are the downward forces, children? One force is 40 Newton, you can see. And other force, that is the weight of the beam itself.
30 Newton.
Yeah, so 40 and 30 Newtons are these two forces acting, but what we have to calculate total clockwise movement. Clockwise movement. So total clockwise movement, I will write here. Total movement, okay. Due to this, let me write this total is equal to first movement due to 40 Newton force plus movement due to 30 Newton force. So that is equal to, what about the movement due to the 40 Newton force? 40 multiplied by its distance from the pivot point. What is the distance of force 40 from the pivot point?
1.2 meters.
1.2 meter. Okay, so you will write 1.20 this value here plus moment due to 30 Newton force. 30 is here. So force is 30 multiplied by this force 30 Newton from the pivot point. From this pivot point, I have to. What is the distance, children?
0.5 meters.
0.5 is correct. 0.50 meter. So multiply and add please all this value and tell me the answer. (40 into 1.20) and then
48 Newton meters plus 50 Newton meters, which will create 63 Newton meters in total.
Okay, final answer is that the total moment about the in the clockwise direction is 63 Newton meter, and this direction is they are also asking about in the clockwise direction. Now in next part, calculate the downward force which the slab S exerts on the end of bar B. Calculate the downward force which the slab S exerts on the end of bar B. Where is this diagram? Downward force that the slab should impart or exert on the bar. So where should I put the sign of arrow? They are asking about here, this downward force, which is unknown now here. I have to calculate this force F here, children. How much force should I apply at this point? Again, let me read the statement. Calculate the downward force which the slab S exert on the end of bar B. How would you calculate, children, this force?
Principle of moments.
Again, yeah, from the principle of moment, you can see this force here, which is acting on the left side. This will make the movement will be in the anti-clockwise direction, children. The force is downward. So this slab will make that the bar to rotate in the anti-clockwise direction about the pivot point. So here the moment due to unknown force F, let me do here, moment due to the unknown force by the slab is given by force, and its distance from the pivot point, you can see in the question in the diagram, children, this distance is here 0.20 meter. So this distance is 0.20, and if I apply the momentum principle, this moment that is anti-clockwise direction should be equal to the clockwise moment that we already calculated, which is 63. So for me, that I will equate the moment of force in the left hand side, that is in the anti-clockwise direction, with the total moment in the clockwise direction. So I will be able to get this unknown force, that is 63 divided by 0.20. Please someone multiply, divide this. 63 divided by 0.20. $315 Newton. Okay, thank you, Kezia. So this is 315 Newton. This amount of force that the slab should apply, should exert. Last part, children. Suggest a change to the arrangement in figure 3.1 that would reduce the force required to lift the slab. What necessary changes you want to make so that that would reduce the force required to lift the slab?
Increase distance.
To lift the slab. Slab is here, children. This is the slab. You want to lift it, and what changes? What distance? What distance? Means pivot should be moved to the right side or to the left side?
Left.
Sorry, please.
No.
Right.
No, this pivot, okay, so this pivot means that the stone should move to the left side. Means if you keep the stone here near to the edges, because this distance we are talking, this distance we have to increase from the pivot point, sorry, from the force that is we have applied. If I make the pivot or the stone to the left hand side, so R will increase. Is this R will increase? Distance of force, that is 40 Newton, it will increase as I move the pivot to the left hand side. Is this clear, children? That it's a simple, but if you read it carefully, then you will find the answer. So you can make here shift the stone to the left side.